Hello everyone, welcome back. In this tutorial or this course I will try to explain or introduce the deep learning in a very simple way with of course with some examples. Yeah, so before diving into what is the deep learning, let's see what is the machine learning itself. Machine learning it's a field of computer science that gives a computer the ability to learn without being explicitly programmed. So it's like, for example, if you already know decision tree, for example, support vector machine algorithms, linear regression, and etc. And let's say, for example, in the training phase, for example, in the machine learning, we have a label data. I'm assuming that we have this dataset, iris datasets, that contains four attributes and one class, and each attribute has values. And the task of the machine learning algorithm is to build the model from this data here. Let's say we use iris datasets, and to build the model that will be able to predict the new uh, columns or rows, sorry, the new class of the new input. So if we assume, for example, here's the prediction. We have the labeled data. So if we assume this is the line 7, but we don't know the class label here. So based on the model we already trained on the same data here, and yeah, the training and testing has to be separated. So means what we use, what we already use in the training, it hasn't to be in the testing. This is the best way, for example, to evaluate your work. And you have, for example, the label data, and you have the learned model from the previous step, and you will try to predict the class label. And the class label, it will be, for example, one of these classes here. Yeah. And what is the difference or machine learning and deep learning? Assume that we build a system that will be classify this, for example, image as a car or not car as object. So in the machine learning, we will have to extract the features manually. I mean, someone will extract these features. For example, let's say edge detection, vertical edges, horizontal edges, corner detections, line detections, and etc. Or maybe color intensity features. And these features will be considered as an input to the algorithm, as we see, for example, support vector machine. And the algorithm will try to predict the class of this input or this image. But in a deep learning, you have the input. The feature extraction and classification will be internally done. So we don't need to take care of the features. Features will be extracted based on the weights, and it will be free modified or accurate. It will be more accurate features to classify these images, for instance. And let's say there's somehow confused between machine learning and deep learning. Deep learning is a part of machine learning indeed. So as you might know, for example, deep learning, it's a neural network. Neural network, it's a type, algorithm of the machine learning. Deep learning. So what's the deep learning here? Deep learning, it's a normal neural network. I think you already have seen this neural network, but with several layers between input and output. And deep learning, it means you have many hidden layers. For instance, in this example, we have five. Let's see, five hidden layers. But in a deep learning, you might have thousands of layers, hidden layers, and you have input, hidden layers, and output. And input layers, it's not considered as let's say layer. It's just as an input, and this is the network. So how many layers we will have here? It will hidden layers plus output layers. It will be 6 layers. Let's see. And this hidden layers is try to extract and processing the features. This is as we said in the beginning. Feature extraction is done in the hidden layers. So why we need to use deep learning? As you know, there's a lot of, I mean, amount of data is getting exploded these days with social media, videos, hand mobiles is try to recording something, and this we need to analyze this data. So if we use the traditional algorithm, it might be not working with this much of data. So the performance will at a certain point will be stopped here, or maybe it's not working. While in a deep learning, if you have uh, much data, your performance will be increased. Yes. And how the neural network is working? Let's assume this we have this short table here, and we have a weight and height, and we would like to try to classify this is a man or a woman. It's just random data. It's not that right. Yeah. So here's we have an input layer. It's weight, height, and we have hidden layer. Let's see some. Let's see. We have one hidden layer. This is only one hidden layer, but with two neurons. And the output layer, it's one layer with one output. The output it's man or woman. Yeah. So this is we would like to try to apply this formula. Why? In our case, why it's a class label, but we see it why. And this is a weight. This each input has weight in this network. Each input has weight, and we need also a bias. Now let's say for instance we'd like to find the first neuron in hidden layer 1. It will be weight multiplied by weight 1. It's somehow this is a value of this attribute, and this weight plus the height multiplied by W2 plus B1, the bias. Oh, sorry, I forgot to add this one. Yeah, sorry. And here's H2. H2 is the same. Here's the input, weight multiplied by W3 and height multiplied by W4. And this H1 has activation function. We'll explain it in details in the next coming videos. Let's see. Activation function is try to squeeze the values of the input here of the output of this formula here between, let's say, 0 and 1, or maybe only positive values, or maybe between -1 and +1. This we will explain it in detail. And this H1 and H2, this is neuron 1, neuron 2. And what about this one here, output? It will be H1 multiplied by W5 plus H2 multiplied by W6. And we know H1 and H2, it's here. It's already defined here. So this is the result of the two lines here. Now we will see the question is how many parameters do we have here. Number of parameters we will have is, if you count it, for example, by hand, because it's a simple network, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 parameters. This is B3. But how to find it if you have a big network? So the big network is if you have number of inputs, we have 2, and number of connections. For example, this connected to this and to this one. So it means 2 multiplied by 2 plus we have 2 multiplied by 1. It's 6 weights, and plus this bias here. Don't forget to add this bias. 1, 2, 3. It means 9 learnable parameters. And try to find this this number of parameters here. It's almost the same. number of input multiplied by number of neurons and plus number of input, this considers also as an input for the second layer, multiplied by 2 plus the bias. Each neuron has one bias. And let's give a good example, or maybe a short example to explain what is the how is neural network work with this example. For example, we have x and y, and assume that you have an x1, in y you will have 2, 3 you will have 4, 5, 6, and etc. And assume that we need to test in this block here, in the 9, in the 8. In 8 we have 9, but let's do it, try to find the value, assume it's not here. Okay, so this is the network xi multiplied by weight, we will get y, we will get this this, for example, this is for only for this example. And y hat, it's, we apply this formula, it's x multiplied by weight plus bias. We assume that PB is 1, bias is 1. So if we assume this is the weight, it's 0.5, we'll multiply 8 multiplied by 0.5 plus 1, it will be 5. This is not right, because the y has to be 9. So that means the weight, this weight has to be updated, this and also this, but it's just for simplicity, sake of simplicity, I will just leave it as 1. And it means 5, and then the actual value is 9. 9 minus 5 is 4. It means we need to increase our weight. So if I assume this 0.7, 8 multiplied 0.7 plus 1, it will be 8.2. We are close to the solution. We need 9 here. So it means this one here, weight will be 1. If we assume this is 1, it will be 9. And this is not just guessing. There's several algorithms applied behind this stuff. So we will explain it in detail how to update these weights here, and what is the right formula to do it. Yeah, and of course we will do some programming also with some platforms. Here's several platforms here, and I will try to do some material videos with Keras and PyTorch, and it might be also TensorFlow. And this, for example, this is just showing how many platforms that we have. This is the well-known famous ones. Yeah, and I think to this point we already finished the introduction, and wait for the next videos. Thank you.